Introduction to Python. Python is an interpreted language. What that means is Python is processed at runtime. It's kind of hard to explain to that right away, but what that means is you don't have to compile the program before executing it. That's similar to Perl and PHP. Java and the C type languages, C, C++, C Sharp, those types of languages, before you run it, you actually have to compile it, which means you have to convert it to machine language before you can execute it. Python can execute from its original Python file type. It's interactive. You can sit at a prompt and interact with the interpreter to write your own programs. And it's object oriented. You create objects, and with those objects you can do stuff. You can assign values, you can add to them, you can subtract to the values within an object. And it's a beginner's language. It's a great language for beginner level programs, supports development of a wide range of applications, from simple web applications, games, robotics, and more. Python programs are composed of modules. Modules contain statements, statements contain expressions, and expressions create and process objects. So let's take a look at some of those. Let's see. Python, let's talk about the modes of operation now. Here we see two examples, Python used as an interactive interpreter. So here we've got Python just opened up in a shell, and you can actually do this from the command line also. You don't have to even have some type of program running. But here I just type in 2 plus 2, and automatically it gives me the result 4. I can create some variables and assign values to them. X equals 5, Y equals 4. As soon as I type print XY, it's going to return the result. So the program is running as I type. So let's kind of take a look at that. I can do that right here for an example. So if I just type Python, or maybe not. Let me type Python. There we go. Okay, so now I'm in the Python interactive mode. So anything I type here is going to execute at runtime as I type it. So 2 plus 2, and right away it gives the result. X equals 5, Y equals 6. And then I can print the result of those two values, or anything I put inside the parentheses is going to get printed. So I'll type X plus Y, and as soon as I hit enter, I get a result. So that's what we mean by the interactive mode of Python. If I run it as a script, as a program, I can do it the same way, do the same thing, but none of this happens until I actually execute the script. In this example, I am writing a script. It's got a file name, example underscore script.py. It's actually a file, a program, and nothing here is going to happen until I actually execute the program. Nothing's happening, so if I go here and run it, and I will run it without debugging, choose my debugger, and now it opens a terminal window on the bottom half of my screen, and it does indeed print the result of X plus Y. Python has modules. Modules is a file containing definitions and statements. A file name is the module name with the suffix .py. So technically this, what I called a program, technically this is a module, example script.py. Right here, there's my module. It's important to understand these terms because when you hear them in lecture, when you talk about it, you kind of have to understand what do I mean when I say a module versus some of these other terms. So here's an example of some code saved in a file named module.py or mymodule.py, and I can use these modules and I can run these modules directly, or I can reference these modules by importing them. That's what this is right here. I can save modules, and then if I want to use them in another program, I can import the module, and we'll take a look at that a little bit later today. And then, so here's a better explanation of module statements and expressions. So there's my module name, and it shows the complete path to the file. And we have statements. A statement is simply a line that assigns something to a value. Anything can kind of be a statement. Now, if this is also a statement, but we have an expression, x plus y is something that we have to solve. We have to do something in an expression. Now, the math operators in Python, we can't quite use all the operators that you're used to in traditional math. If we want to do an exponent, a power of something, we have to use the double asterisk. If I want to find the remainder of a value, what is the remainder of 100 divided by 3? Or in this example, 25 divided by 4. The remainder is going to be 1. That's how we get the remainder of a value if we're dealing with whole numbers or integers. If we want to do integer division, this returns just the integer. We can use the 2 of the slashes. If we want to do standard division, now this is going to return a decimal number. If I don't want the result in decimal form, then I'll use 2 slashes. If I want to multiply, well, I can't use the x for multiplication because that's going to be interpreted as a character, not a math operator. So we use the asterisk for that. Subtraction and addition, those are the same. We have different data types, and this is important to understand too, because different data types are stored and they're converted into binary data separately. So we need to make sure that we understand what data type we're working with, or we'll run into problems and Python won't understand how to evaluate the data. So let's take a look at numeric values. If I store a data type as an integer, you can see here the binary conversion. It just stores it in numerical values in binary. If I want to store a value as a character, we have what's called the ASCII, American Standard Code for Information Interchange. And this is really what they did, is they assigned a numeric value to every possible keystroke on your keyboard. Capital, lowercase, function keys, maybe not the function keys as much, the special characters, the space, the tab, the return key, all of those have a numeric value assigned to them between 0 and 127, and then those are converted in binary to different values. So here's the complete ASCII table. So some of these characters, start of text, end of transmission, not necessarily keyboard characters, but we do have a character for the backspace. So when you hit the backspace key, that's represented as 00010000. And then the delete key is all ones. And then you can look through here and let's see the characters. We start with spaces. We have actual characters, because if you type the letter 0, that's got to be represented as a character as well, because it can be sent as that value. So we have all the number keys, and then we have the special characters. Then at character 65, we start with capital A through Z, some more special characters, and then at 97, we start with lowercase a through Z. So this is one of the problems you can run into with Python, or with any programming language, or even databases. You have to kind of declare, or you have to understand whether a value is a number or a string. If I take the value 101, in binary, that can be converted 1100101. Now in ASCII, if you convert as just the key number 1 as a string, you would have 8 bits for the first digit 1, 8 bits for the 0. That can't be right. Oh yes, that is the ASCII string, because that's not binary conversions. This is just a position in that table we looked at. So that represents 128, that represents 96. And actually I can go back to that. 96. Let me double check that. 1, 2, 4, 8, 16, 32, 48. It's a 7-bit value. So if I go back here to 48, it's the character 0. And then let's go and look at string concatenation or replication. This is where this can be kind of important. I can take a string and I can combine it with another string, and that's called concatenation. So if I want to print the string October and or concatenated with November, it would be October, November. Notice there's no space in there. If I want to put a space in there, what I've done this time is I've done October plus, and then I put a space before I type the word November. If I want to replicate a string multiple times, I can print October asterisk 3, and it's going to print October 3 times. And if I wanted them spaced out, I could just put a space here before my ending quotation mark. Now, if I want to concatenate different data types, that's a problem. You can only concatenate strings. So I could try to concatenate October to the number 11. By default, when you type a numeric value in, it's going to treat that as an integer. And I get this error. And get used to these errors. Don't panic when you get an error. Happens all the time. And there's a lot of text here, but try to take a look at it and you'll start to get the hang of it. In this case, you've got a type error. Well, a type error means that you're trying to do something with the data type that is not supported. And if you read the message, you can only concatenate strings, not integers. So then you can just double check there and say, okay, well, I'm trying to concatenate a string to an integer. Where's my integer? Oh, there it is. So how we can get around that is there's a string function. And the string function will take any value and convert it to take a numeric value and convert it to a string. And then I concatenate. So I'm going to call the string function, and inside of the quotation or the parentheses, I'm going to convert that 11 from a binary value to ASCII. And then when I print it, it will actually print the way I want it to. So here's an example of a string data. If I'm defining a string, I have to put it in quotes. If I don't put it in quotes, it's going to think that I'm referencing a variable. And if the variable is not defined, then I'm going to get a name error. So what it's saying is you're trying to do something with October, but October is a variable and you haven't told me the contents of October. So if I go ahead and I define a variable month as being October, the string October, then I can print month, and it's going to say, okay, you want me to print whatever is contained in the variable named month. I want to concatenate a string into an integer. Day is an integer. Month and day, I get this error. I can only concatenate a string, not an int to a string. So I cannot do this. I can't combine the two. So let's take a closer look at the string function. The string function is going to take whatever I put inside of the parentheses and convert it into a string. In this case, day is equal to the number 11. And when I put day inside the string function, it's going to return the result of that function, and that is going to be 11 as a string. So let's talk about variables. Variables is a container in memory that stores a single value. Variables are created using assignment statements. So I'm going to assign a value to October, and I'm going to assign a value to the string or the variable named day. And if a variable is ever assigned a new value, the old value is forgotten. Forgotten, overwritten, however you want to phrase it. In this example here, I create a variable, and in that variable I store the string October. And then I don't really recreate it, but now I'm overwriting it. So I'm taking whatever month is and I'm changing it to the string November. Now when I print the variable month, it's going to display November. Variable names should describe the data it contains. If you start creating variables X, Y, Z, You better be very careful with them, and really, I wouldn't do that unless I'm only going to use it for maybe a couple of lines in a program. If you start creating variables that aren't clear as to what they represent, you can get yourself very confused. They can only use letters, numbers, and the underscore character. No special characters other than the underscore. Cannot begin with a number, and they are case sensitive. So here I have lowercase month, October, uppercase month, November. If I print lowercase, I get October. If I print uppercase, I get November. So here's some examples of valid and invalid variable names. Current underscore day, that's good. Underscore, I can't use the hyphen in a variable name. This would confuse it. It would think it's multiplication, or I'm sorry, subtraction. I can use current capital D, and that works. What I can't do is I can't put a space between two words in a variable name. And then I can use numbers after the first character. I can have employee 13. What I cannot do is I cannot create a variable beginning with a number. As soon as I start typing numbers, Python's going to default and try to treat these as integers. It's just not going to like it. We have two different name styles. When I took my first programming courses in Java, we used camel case. And basically we start with a lowercase character, and then every new word is a capital, the first character of every new word. Send capital C command, disable capital P paging. And you'll see a lot of references using that, and sometimes you'll see Python documentation doing that. But this is the format that I'm going to encourage you to use. Average underscore daily underscore balance, send underscore command, disable underscore paging. And the way we're going to do that is because, like I said, some references will use camel case, others will use underscores. The official Python code says underscores should be used. So most of the documentation you're going to reference will use underscores. We're going to use this Python module named NetMiko, and it's going to contain a lot of the functions we use, and it uses underscores for all of its function names. So for this course, I'd prefer it if everybody uses underscores to maintain consistency. But it's also important to understand that some people, maybe somebody programs in multiple languages and they've gotten in the habit of doing it one way. If you go and you post a question in a forum, you might get results back using underscores. Be prepared to see variables created using camel case as well as underscores. Here's an example of the NetMiko documentation page. You can go here and you can look, and here's some functions that are created, and you can see right there all of the NetMiko documentation, all of the Python documentation. It's going to use underscores. Let's talk about comments. Comments are for programmers to better understand the functionality, and they become essential when you start getting into longer programs. If you don't use comments well, you'll come back to a program. I've done it so many times. I come back to a program like the next day, and I'm looking at something and I'm lost in the program. I don't know what this section of code is really doing. So if you don't comment your program well, you can get very confused. Slow and steady wins the race. Take your time, put good comments in there so you know what you're doing. Here's an example of a comment. Anything after the hashtag is ignored. And notice here in my editing program, my text editor that I'm using, I can create anything is ignored after the hashtag. And notice how it's in a different color here. Usually it's going to be in green, but not always. You can set up the coloring in your editors. It's not a standard. Every comment doesn't have to be green, and every term here doesn't have to be. These colors are going to change a little bit for you. So we can also do, if I want to do multi-line comments, I can start with 3 either single or double quotes, and then I can type whatever I want, lines and lines and lines, and then I end my comment text with 3 more quotation marks. Functions. A function is a block of code that's used to perform an action. Functions provide better modularity and a high degree of code reuse. I can pass data, known as parameters, into a function, and a function can return data as a result. So let's take a look at that. Here's some of the libraries. Python comes with a set of built-in functions. We already looked at some of those. We looked at the print function. We looked at the string function already. There's an int function. You can import additional function by downloading these modules. You can find them at the Python docs pages. And basically what this is if you excuse me, if you added every function, if you tried to import and load every function into memory to do something, to run your Python program, you would probably crash your computer. There's so many modules. So think of this as just kind of like different programs on your computer or different applications on your cell phone. If you went out there to the internet and you downloaded every app in the App Store onto your phone wouldn't store it all. And if you tried to run them all at the same time, you'd run out of memory. So these additional functions can be added, but you only really want to add them when you need them. You don't really want to be running everything. And you have to understand too, if you use a function, then that function has to be stored, has to be brought into memory for your program to execute. So you don't really want every possible function stored in memory so when you execute it, it actually knows what to do. So they're out there, and basically it's kind of like an a la carte menu. You load them into memory as you need them. If you need them, if you don't need them, they're out there, you can use them later. So here we can look at the modules. So from the interactive mode, if I go in here and type help, I go into the help menu of Python, and then I can view all the modules. And these are all the modules that come built in with Python. This is not the complete list, a couple of pages of all the built-in modules that you can use. Now some of the common functions are the print function, the input function, the length function, and then the conversion functions here, string, int, and float. So let's take a look at the print function. So here's the print function. I'm going to print, and what it does, it displays the string value that's put inside the parentheses. So here's the function, and then here's the values that I'm going to pass into the function. So in this case, I'm going to pass the string hello world into the print function, and it's going to print hello world. If I want to display the value stored inside a variable, I can create a variable, and then I can print name. Notice name is not in quotation marks. Variables cannot be quoted. If I put that in quotation marks, it will print the string name. I can also do it with values, integers. I can print a variable stored as 10. This is still an integer, but it's going to print the amount. And I can actually also, I could do print 10 and it would print 10 for me. And lastly, I can concatenate strings with the plus symbol. So I can print, here is a string, and then I'm going to add to that string the contents of the variable name, which in this case is Bill. The input function is kind of neat. What this does is this prompts the user of the program to input a value. In this case, we're going to create a variable called user input, and user input is going to be the result of the input function. And what the input function does is it pauses execution of the program until the user enters a value. So when I type, what is your age, it's going to pause the program and prompt you for a value. So we can actually do this, and let's look at this in lifetime. So I can type input, and that's going to be equal to, I'm creating a variable, and let me get over here, I missed it. And it's going to be equal to the input function. Now I have to post a message. And I'll just simplify this a little bit. And then I have to close the parameters of my function inside of the parentheses, and then I'll put the string age here. And then as soon as I hit enter, it's going to prompt the user for a value. User. So that's in the interactive mode. Now if I do it in an actual program, let's bring this over and we'll do the same thing. I'll just do it this way. Just expand this. Okay. Input, and then I'll say so I'll create this, and then I can type. So now I've got the input function, and I'm going to print the age. And my program is going to pause until I do something. So now if I go and run this program, notice here, my program stops. It's not going to do anything. It's not going to go to this step, printing the age, until I actually type a value in there. And then it goes to the next line of code and executes that step. That's kind of neat about the input function, that it does actually pause code execution until you do something, until you enter a value. Now the length function is going to return the length of a string. If I need to know the length of a string for some reason, that's useful for finding the first characters, the last characters, finding characters based on their position number. That's going to return. So if I create a variable named text length, and that's going to be the result or the return of the length function, I have this variable named text. Text is going to be equal to this string right here, and then I can print text length, and that's 49 characters long. Concatenation, we talked about this a little bit earlier. I can concatenate strings with the plus symbol. I cannot concatenate strings to integers. So here we can do it. We're going to get this type error. Remember, don't panic if you see errors. Read the errors. They're trying to explain to you as much as possible what the problem actually is. And here, if you ever get a type error, then you need to look at your types, your variable types, your string types, whatever your data type is. You want to look at that real closely and say, where's the problem? And this is one of the things with Python. Python, when you type a value in, you don't necessarily declare the data type. If you've done anything with Java or C, with those programming languages, you cannot create a variable without first telling the program whether it's an integer, whether it's a string, whether it's a decimal number. So because of this, you kind of have to really pay attention to your data types. In this case, the zip code, that looks like a number to Python. It's not really, because we don't do mathematical operations on it. It's really intended to be a string. But in this case, Python's confused because it's storing this value as a numeric value, and it won't concatenate to a number. So obviously we can call the string function to fix that. And then here in this example, I have 3 strings. They're clearly strings. They're in single quotes. And you can use double quotes for this too. Quotation marks don't matter. Single or double doesn't matter as long as it's consistent. And notice here in this concatenation, I'm going to print the city and comma, space, and the state, and space, and country. And here you get Plano, comma, space, Texas, space, USA. String, int, and float functions. We have these are our conversion functions. We can convert values to a different data type. So if I want to create a city, a state, a zip code, I can change zip code. So I'm going to overwrite the zip code stored as a integer and convert it to a string. And now I can print it, concatenate it the way I want. And there's a type function, and this is just going to return the variable type. In this case, if I create a value 3.14, that's what's called as a floating point value. And a float is a number with a decimal point. And think of the float as, well, that decimal point can be anywhere within the value. We don't, as far as the Python is concerned, it doesn't really know where that decimal point, which position in the number that decimal point is going to be. So that's why it's called a floating point decimal. And then if I want to print, and then I'm going to call the type function. And inside of there, what type of value is pi? And it will be class float. And sometimes I'll actually do this in my program just so when it executes, it will print a line telling me what the value is. There's other ways around it. So here in this case, pi equals 3.14, print pi. I can print pi as an integer and only get 3. And I can convert it to a string. If I convert pi to a string, it will print it, convert it as a string value. It looks the same, but now it's stored as a string that I could concatenate to. And then if I did this, I don't know where the rest of that example is. Let's take a look at that. Let's go into, let's just bring this open here. Actually, let's do this in VS Code. So if I come in here to VS Code, I've created my program, I've ended it with .py. So now all I have to do is, let me get rid of this. And what was that last example? Let's look real quick. Go to the last slide. X equals 2, print x as a float. X equals 2. And then I have to put a parameter inside my float function, and then that float function is nested within the print function. So let's do this and see what happens. And there we go. It printed 2.0 as a floating point decimal as opposed to an integer. Actually, let's do it this way. If I print x, the first time it printed x, it printed 2 as an integer. When I convert it to a float, it's going to put a decimal point in there and at least one decimal place as a floating point value, even if it's a whole number. So let's take another look at some things too. I want to show you debugging real quick. So if I do equals 3.14, string pi is going to be equal to, I'm going to call the string function and I'm going to put pi in it. So I'm going to take pi and convert it to a string. And then I'm going to take and then I'm going to go ahead and I'm going to create a variable called integer pi. Let me just, I don't even want to print. I'll throw that in here. What the heck? Okay. So another way we can look at our variable types is I can use debugging. We just kind of saw that. You saw it there when I tried to run the program. So what I'm going to do here is I'm going to click each line of code that I want my program to pause at. And that's kind of why I put a print function in here, because I won't be able, you'll see it when I do it, but I won't be able to debug this line unless there's a next line to go to. So how this works is I'm going to run my program, and now I'm going to run it in debugging mode. And I still have to choose my Python file that I'm going to debug. And now when my program executes, it's going to pause at each line that's got a red dot or a breakpoint at it. So actually it pauses before the line executes. So right now if I highlight over pi, it doesn't really know what pi is. There's no value here. When I click this to continue, now I can actually highlight pi, and it tells me that pi is equal to 3.14. So I can look at these variables, and that'll help me define what they are and the type. So this is really useful in your programming to use the debugging also, because then you can just kind of pause your program and look. And here we can see string pi, and it's telling us that it's a string, but it's not really showing the value as a string yet. We know what pi is, but string pi doesn't have a value assigned to it until I click the next line of code. So now we can see the contents of string pi are 3.14 inside quotation marks. So we can see right there that that's a string value, not a floating point decimal. And then if I go here to int pi, we don't see a value for int pi. We know that it's going to be an integer, but we can't really see the value of it. So when I take to the next line, now I can actually see that int pi is the value 3. And this is why I had to put a print statement in here, because the program would have ended before I ever really got a chance to look at that. So anyway, I hope this helps you with everything for Python. Good luck, and thanks for watching.